This is homework number 2, problem 10, which states that standing waves on a 1 meter long string that is fixed at both ends are seen at successive frequencies of 36 and 48 hertz. A, what are the fundamental frequency and the wave speed? And B, draw the standing wave pattern when the string oscillates at 48 hertz. So starting with part A, we know that the length of the string is 1.0 meters because they gave that to us. We have some frequency at 36 hertz, and we have another frequency at 48 hertz. So they gave us a little more information. They said that they're successive. So we know that this one is some harmonic times the fundamental, and this one is some harmonic plus 1 times the fundamental frequency. So we want to find this fundamental frequency for part A, and we know that these come in an order, so we can turn this into a ratio. We can say that FB over F of A equals M plus 1 times the fundamental over M times the fundamental. And then again, we know that this is 36 hertz over, F of B is 48 hertz over 36 hertz. So these fundamentals cancel out, and we end up with, this simplifies to 4/3, and we end up with M plus 1 equals 4M over 3. If we multiply that M to the other side, multiply both sides by 3, 3M plus 3 equals 4M. And if we simplify this out, we get that M equals 3. So to find the fundamental frequency, we can plug that in to one of the equations. So we know that 36 hertz equals MF1, and we would divide by M, so we divide 36 hertz by 3, and we would get F of 1 equals 12 hertz. So that's going to be our fundamental frequency. Now we want to find the wave speed. So we know that velocity equals lambda times frequency. It's one of the equations we were given. We also know that lambda equals twice the length over which harmonic. So we can plug lambda in for here because we know length, and we know that this can be the fundamental frequency. So if we have 2L over 1, because we're using the fundamental frequency, we know that this goes away, and we have 2 times 1 meter, which they gave us, times 12 hertz. Now, when we multiply that out, we get that the wave speed, V, equals 24, we're going to unit meters per second. So there's the wave speed. So now that we have our fundamental frequency and our wave speed, we're done with part A and can move on to part B. Part B is asking us to draw the standing wave pattern when the string oscillates at 48 hertz. So at 48 hertz, we know from our equation up here that 48 hertz has to equal some M times the fundamental frequency. I didn't write N plus 1 for this case because I'm no longer comparing it to the 36 hertz. So because we know our fundamental frequency, we can divide this by the fundamental frequency to cancel that out, which is 12. So we get 48 hertz divided by 12 hertz. Our units cancel, and we end up with M equaling 4. So we know that this is the 4th harmonic. So now that we know this is the 4th harmonic, we can find the wavelength. So we have this equation again. So we know that our wavelength equals 2 length over M, 2 times 1.0 over 4, which equals 0.5 meters. So we know that we should have 4 peaks, 4 antinodes, and that the wavelength between each one should be 0.5 meters. Not between each antinode, but between each wave, basically. So we can draw our picture. I'm just going to set my boundaries. I'm going to draw 4 antinodes, so 4 peaks and troughs. Not the best drawer. And then I'm going to go back and connect them. So we know this is a 4th harmonic because there are 4 peaks. If we wanted to put some more information, we know that this whole thing, we know that our length is 1 meter. And we know that our wavelength, which is the length of one wave here, so from this point to this point, 1 peak and 1 trough, is going to be 0.5 meters. And that's how you would draw the wave pattern of a string oscillating at 48 hertz. And that's homework number 2, problem 10.